to Major Migrations Made Easy. My name is Tim de Beek, and I'm a Java consultant at JDriven. And coincidentally, it's my birthday, so glad you all could make it. I'm happy to be here to present on a topic I'm passionate about, which is automating major migrations. I do a lot of these migrations as a consultant, as I switch between companies about every year. Typically, my assignments see me bring outdated technology stacks back up to date. And I love the temporary moment of zen, when everything is just right, running on all the latest versions. But then, soon enough, I switch to a new assignment and get to do the same thing all over again. To give you an idea of what types of migrations I'm talking about, I'll give you a brief overview of changes over the past decade. And as we go through this list, I want you to imagine how you would automate each of these steps. I started working professionally with Spring in 2009, or Spring Framework 2.5. To give you a bit of an idea, annotations were the new thing back then, as an improvement over the XML configuration that came before. My team and I worked on a single service connected to a single database, and all of this was still on Java 6, with the odd bit of SOAP and applets thrown in here and there. In 2011, Java 7 came out, and with it improvements such as automatic resource management, the diamond operator for type inference, and new file input and output classes. Nice, small improvements with clear before and after semantics, which we eagerly adopted by hand. Then in 2014, Java 8 came out, and with it came Lambda expressions, a major new language feature that significantly improved code readability, especially when frameworks make heavy use of anonymous classes. Java 8 also came with the new date and time APIs, meaning we could phase out utility libraries such as jo.time. This took some more time and effort, but it paid off eventually. Spring Boot was released in 2014, which greatly reduced boilerplate around project setup. I remember thinking at the time I wouldn't need all that, but I was terribly naive. So another few rounds of upgrades to reduce complexity. Then building microservices came out in 2015, and with it the trend of decomposing applications into multiple deployments, each with their own data store. This brought with it quite some complexity in communication and fault tolerance, and architecting for platforms such as Kubernetes and the cloud. It also meant that whenever we upgrade Spring or Java, we now get to do it not just once, but dozens of times. 2017 saw the initial release of JUnit 5, meaning it's been going for close to 6 years now. And yet, I still see JUnit 4 being used or required to be on the class path, even with modern tools such as test containers. Java 11 came out in 2018, and while there were some nice improvements, there were also challenges with regards to now required Java X dependencies. And even today, some organizations still have to overcome this hurdle. Also in 2018, Spring Boot 2 came out, which at least meant Java 7 was now out of the picture. Upgrading required careful attention, especially around configuration binding and actuator properties. And don't forget to also upgrade Spring Data, Spring Security, Spring Cloud, and messaging. And repeat that as you adopt each new version. GitHub bought Dependabot in 2019, so at the very least we can now all be aware of the version upgrades we are postponing. RenovateBot can offer much the same on GitLab. In my opinion, a tool that services new versions should be the bare minimum for any company, but I find it's often still missing. And these tools do not patch your code. They only increase the version number. When your build then fails, you know you still have work to do. And even when your build passes, you might still have work to do, as configuration properties and non-functional changes might only surface at runtime. Then just last year, Java 17 came out. And with it, you get cumulative features such as text blocks, records, pattern matching, switch expression, and strong encapsulation. All nice improvements with clear applications, but each requires some effort to adopt. And tooling in this space is still catching up. And just the past 6 months, broadly applicable vulnerabilities, such as Log4Shell and Spring Shell, highlighted how we need to react quickly to adopt new releases. You know you will have to migrate eventually anyway. Why waste evenings and weekends to do so in a hurry? And finally, looking ahead, we can see Spring Framework 6 on the horizon, along with Spring Boot 3. I don't want you rushing out the door, but right now, Jürgen is telling his audience all about the new Java 17 and Jakarta EE9 baseline, which are guaranteed to have an impact on your code. All these examples taken together make clear there's a near constant stream of worthwhile improvements to pick up. And it's what I love about open source software. You get all this functionality for free. The only downside is you have to keep up and try to stay current with recent developments. And I like the challenge, so I still get excited whenever a new version comes out. I just don't like the repetitive elements that come with upgrading. And if you try to keep up by hand, you will hardly get anything else done. Automation may be the only option, especially for large companies maintaining thousands of services. So imagine my excitement last year when I discovered OpenRewrite. OpenRewrite promises to make light work of all such migrations. With a simple command, you can now upgrade between versions of Java and Spring. You can even migrate between frameworks, such as from JUnit to AssertJ, and even from Java EE to Spring. In this talk, I will tell you all about OpenRewrite, how it came about, how it works, and what you can do with it. I'll tell you all about Spring Boot Migrator, an experimental Spring project that builds upon OpenRewrite to help you upgrade or migrate to Spring Boot. Finally, we'll briefly look at who is developing these recipes and how to apply them to open source projects. So, OpenRewrite was started at Netflix, initially to aid in the migration of an internal logging framework to SLF4J. You can probably imagine any logging framework is going to be pervasive throughout an organization. To even consider migrating, you would need perfectly accurate automation, especially when usage is spread across hundreds of services. So they developed a parser to accurately read Java and turn source code into an abstract syntax tree. This model can then be modified to replace the old logging statements with calls to SLF4J. Next, the migrated model is written out as close as possible to the original source code. This way, the applied changes are minimal, leaving surrounding code untouched. Later, the same developers moved on to work on Spinnaker. While trying to onboard teams and organizations there, they found teams often struggled with the same outdated libraries and frameworks. To help these teams adopt the latest versions, they applied a different set of transformations through the same abstract syntax tree parser. This allowed them to quickly reduce this technical debt, bringing teams from Spring Boot 1 to 2 and from JUnit 4 to JUnit 5. The project has since been open sourced, with the company behind it committed to make all recipes available under the Apache license for open source software. The initial focus for OpenRewrite is on Java virtual machine languages and surrounding technologies. There are parsers for Java, Groovy, YAML, and XML. These in turn unlock support for build tools such as Maven and Gradle, and libraries such as JUnit, AssertJ, and Guava. Ultimately, refactoring entire frameworks and platforms is supported, with recipes available for application frameworks such as Micronaut, Quarkus, and Spring. OpenRewrite is not the only parser capable of understanding and manipulating Java. There are other parsers, such as Java parser, which can achieve some of the same functionality. However, two features set OpenRewrite apart from the competition. The first is their focus on exact type attribution. By having the exact type available on any tree element, they can be sure to only manipulate exact matches. The second characteristic that sets OpenRewrite apart is their format preservation. Their parser not only takes into account the functional code, but also the surrounding code style and indentation. This allows them to accurately reproduce your source file, regardless of further changes. Any changes made through OpenRewrite will just look like a colleague worked on your code. Together, these features make OpenRewrite exceptionally good at safe code transformations. Their changes are minimally invasive and guaranteed to work, in part due to their do-no-harm mentality. By manipulating the full abstract syntax tree, OpenRewrite can far exceed simple search and replace operations. With the full abstract syntax tree built, we need to instruct OpenRewrite what operations to apply, where in your code. Recipes are how you define such a group of search and refactoring operations. Together they accomplish a higher level task, such as a framework migration. Recipes can consist of a single standalone operation or be linked together with other recipes. OpenRewrite comes with a large collection of fine-grained recipes out of the box that can be combined for common migration steps. You can think of these as Lego building blocks, ready to be applied with the proper parameters. There are hundreds of these building blocks to, for instance, change types, change methods, change arguments, manipulate properties, and alter dependencies and plugins. Individual recipes are implemented as Java visitors that first match and then modify elements of the abstract syntax tree. There are plenty of examples available, but note that you only need a Java visitor when none of the existing recipes can achieve your goals. Typically, you can get very far only configuring, combining, and applying existing recipes through a YAML configuration file. Modules combine and group together these fine-grained recipes into more coarse-grained application-specific recipes. There are modules, for example, for logging frameworks, testing frameworks, and application frameworks, such as Spring. Think of these as Lego sets with build plans for common migrations and fixes, ready to be used. In my opinion, the abstract syntax tree, combined with a large collection of open source recipes, is what sets OpenRewrite apart from other similar tools, such as Google Error-Prone's Refaster. Now I want to show you how migration recipes are configured in OpenRewrite. Let us briefly look at a migration from JUnit 4 to JUnit 5. I want you to imagine what steps would be needed for a JUnit 5 migration. You likely know a couple of the steps already. Among others, you would have to update the test annotations. But you would also have to update the assertions and sometimes the argument order. You'd have to update all imports, update any test rules, other libraries such as Mockito and WireMock, and that's just getting started. Notice how each step is reflected as a separate recipe in this YAML configuration file. Some refer to and configure generic steps, such as the change type recipe. Others are implemented as an imperative step, a dedicated Java visitor that changes the abstract syntax tree. All these steps combine to achieve a complete JUnit 5 migration. And this is a common pattern with OpenRewrite. Large migrations are broken up into small, reusable steps. Running migration recipes is fairly straightforward. First, you apply a build tool plugin for OpenRewrite. I've used Maven in my examples, but Gradle works just as well. Then, depending on the changes you want to make, add a dependency on the respective OpenRewrite module. Lastly, run the OpenRewrite plugin with the migration recipe that you want to execute. To show you just how easy it is to migrate a project, I've prepared a small demo. For this demo, we will upgrade an old Spring Pet Clinic branch from Spring Boot 1.5 on Java 8 all the way to Spring Boot 2 on Java 17. We will look at the commands and changes made in detail along the way. And since I'm terrible at multitasking, I'm just going to run a demo. So I'll show the commands at every step, and yeah, you can just follow along. So first we check out the 1.5 tag of the Spring Pet Clinic project, which I have already checked out locally. Next, we ensure we are running Java 8 for now, for which I'll use SDKman to easily switch between versions. Then we upgrade the Maven wrapper for compatibility with plugins and to add some color to the output. And we commit the results to have a clean slate. We are now running Spring Boot 1.5 on Java 8. We can see we are indeed running Java 8 from the output. And we are indeed running Spring Boot 1.5. And there are no further outstanding changes. Next, we add the OpenRewrite plugin to our pom.xml file. This works much the same as the Apache Maven wrapper, and that you can use the plugin to install the plugin. If we list the changes in the pom.xml file, you can see that it's been added to the build plugins section. The OpenRewrite plugin has a discovered goal to list available recipes. This helps to find the exact recipe name that you want to apply. Without using any further modules, you can see that there are already 217 recipes available. It also has an interactive discovery mode, which allows you to drill down into available recipes. You first drill into the organization namespace, and then we go for OpenRewrite. We want to try to find the Spring Boot 1 to Spring Boot 2 migration, so we're going to go for the Java recipes in this case. Within Java, we're going to go for the number 27. We're going to go for Spring recipes. And out of the Spring recipes, we're going to go for the Spring Boot recipes. You can see that there are already 52, 53 recipes available just for Spring Boot. We're going to specifically go for number 43 for the Spring Boot 2.x migration. This gives us the exact name that we need to apply for this recipe. We will now migrate the Spring Pet Clinic from Spring Boot 1 to Spring Boot 2. We again use the Spring Boot module as a dependency, and we run the recipe name that we just discovered. Running this command on my machine typically takes about 15 seconds. As the plugin scans your code and your dependencies and builds up a model of your code. The output is not ideal, but you can see that every change made to a file is linked back to the recipe that made the changes. We will now look at the changes in more detail. Our application has been upgraded to Spring Boot 2. One of the changes made is that we had to switch from Hibernate validator to the JavaX validator. And the change is going to be visible in this class. This is just an import change, which is fairly easy. Also updated is that we've removed any unnecessary auto annotations. This helps to make the application feel more recent after a migration. It's not just an old application converted. Next, any web parameter arguments have also been removed, where the argument could be deduced from the parameter name, as you can see here. This again makes it feel a bit more like a recent project rather than an old one. Our application properties have also been updated. This is a quite important step, as your compiler will not help you make these changes or find these changes that are still missing. Our database initialization properties have been changed, as well as our actuator properties. Our pom.xml file contains updated plugins and dependencies. Starting at the top, you can see we're now running Spring Boot 2.5. We gained some dependencies, we lost a few, just to be compatible with the new Spring Boot version. Next, we're going to look at how the JUnit migration has run. You'll notice quite a few changes, which we'll go through from the top. First thing, our imports have been converted into the new JUnit 5 imports. Next, we see that our Mockito runner has been replaced by the extension. Our lifecycle annotations have also been replaced by the new JUnit 5 lifecycle annotations. And any visibility modifiers that are not needed in JUnit 5 have also been removed. Now, most interestingly, we can see how OpenRewrite shines through when it comes to converting expected exceptions. Having the full power of an abstract syntax tree, combined with a Java visitor, allows us to adopt assert throws. These types of changes would not be possible with a simple regular expression approach. And this is just a small sample of the types of changes made possible by using OpenRewrite. Satisfied with our changes, we again commit the results. We are now running Spring Boot 2.5 on Java 8. Next, we will migrate to Java 11 using a different module. The Migrate Java module contains recipes to adopt new language features. You can see the new coordinates for the module, and we use a different recipe. Again, we have to scan the application, but this time it's a bit faster. And I reckon it's going to take 10 seconds. Again, you see the changes made to our pom.xml file have all been attributed back to the specific recipes that made those changes. And if we browse through the changes, we can see that a number of significant changes have been made. The compiler, source, and target versions are updated. We've updated a specific plugin that's only compatible on the latest version. Let's check here. So the compiler, source, and target versions are updated. This one had to be upgraded. Most importantly, we gained the JUX-B implementation, which is now needed on Java 11. Cobertura is not compatible with Java 11, so it's been automatically removed. And we gained the deprecation scan plugin to ensure there's no further incompatibilities. Individually, these might seem simple changes, but by automating these changes, we can run them in bulk, at scale, to upgrade our entire application landscape in minutes. We update our JDK to now use Java 11. And we again commit the results. We are now running Spring Boot 2.5 on Java 11. There is not yet a recipe to migrate to Java 17, but we only have to upgrade the version property for now. And the changes are very minimal. You can see we only update this one. We update our JDK to now use Java 17. Running on Java 17 with the current version of OpenRewrite needs a few additional flags. So we add these to our Maven JVM config. To finish up, we remove the OpenRewrite plugin now that we are done with this migration. And with a final commit, we complete the migration. We are now running Spring Boot 2.5 on Java 17. So to see how we actually did, we're going to run Maven Verify. I know for a fact there will be 2 test failures, one related to the validation change and another related to the response type change. This will take a few seconds again, but I'd reckon it's not a bad result to have an automated migration and only have 2 actually interesting changes to have to make after the fact. So like I said, 2 failures, and that's it. So let's return to the presentation. Now that we've seen how OpenRewrite works, let's have a look at what you can do with it. Obviously, by now, we've seen that it is well suited to migrations. You have mostly seen migrations from one version to another, but you can also migrate from one framework to another. If you want to switch from Log4j to SLF4j, you can. Same thing for switching between JUnit and AssertJ. And even larger migrations are in development. Another application is fixing static analysis findings. A large collection of Checkstyle, Sonar, and security findings are supported to allow you to reduce your technical debt in minutes. Finally, there's a whole class of recipes to enforce code style. Rather than merely apply a formatter, these recipes go a step further to actually change your code. This ensures your code style reads consistently from project to project. And in addition to what's already available, it's fairly easy to add custom recipes specific to your projects. So, now that we've seen how it works and what it can do, let's briefly look ahead at what is still to come. As you've seen, OpenRewrite has dedicated parsers for multiple languages already. But as you can imagine, they have some catching up to do still. They are working on a parser for both Java 17 and Kotlin. Note that you are perfectly able to run on Java 17, but you cannot yet migrate to any of the new language features. The interesting about Kotlin is going to be that Java migration recipes will just work, even though the languages look very different. There have also been experiments to support TypeScript, and although promising, it has not yet been made available. All 3 of these features are in active development. It's not yet clear when you can use any of this, but interesting developments nonetheless. And there's another big new development that brings us to the next section of this presentation. Spring Boot Migrator builds upon OpenRewrite and aims to help developers upgrade or migrate to Spring Boot. It started as a VMware Labs project late in 2020. They started out using the Java parser library, but then switched to OpenRewrite for the improved type resolution. In January 2021, Fabian Kruger took the lead in developing Spring Boot Migrator. And Fabian is with us here today. So if you have any specific questions, do come up to the front after this talk. 2 months ago, the project was open sourced under Spring Experimental. It provides an opinionated API for migrations to Spring Boot, and it remains compatible with OpenRewrite to run OpenRewrite recipes. It's a strategic product for VMware to aid developers to move towards Spring and related cloud technologies. With a strong focus on Spring, it goes beyond what OpenRewrite offers in terms of recipes. It better understands your Spring applications and uses higher level abstractions for concepts such as configuration properties and profiles. If you have a Java EE application that you would like to convert, Spring Boot Migrator will help you on your way. The same is true for converting MuleSoft to Spring integration. These are actual VMware customer use cases that have already successfully migrated. In general, the aim is to help developers to automate tedious migration steps. But as you can imagine, these conversions are hard to fully automate. That is why Spring Boot Migrator takes a different approach of informing through an interactive process. To start out, you scan your application to generate an HTML report. This report details what components have been identified in your application and what actions can be taken at this time. The report will point you to the applicable documentation so you can make informed decisions as you convert your application. It also means you don't have to be a Spring expert in all aspects to help in a migration. Once your application is scanned, you can apply any of the applicable recipes. Some will be fully automated. Others are a mix of manual and automated recipes. As you apply each recipe, Spring Boot Migrator will update your application and commit the changes to your Git repository. Now imagine having this interactive workflow integrated into your development environment. It'd be like having a Clippy assistant that's actually useful. Looking ahead, there's also quite some plans specific to Spring Boot Migrator. Top of the list is helping users migrate to Spring Framework 6 and Spring Boot 3. These releases are expected in November, and contributions are encouraged to help prepare. Another possibility is introducing new Spring modules into existing applications. This already works for Spring Cloud Config, with other additions still to come. Spring Boot Migrator can also help generate code specific to your project. If you convert an application to Spring, you will likely want some tests to go with it. Finally, the iterative analysis and guidance is a perfect tool to move towards a cloud migration or Graal VM. As a last subject, I think it's only fair to tell you a bit about the company behind OpenRewrite. As I said before, they have committed to making all recipes available open source. Their focus is on applying recipes at scale. Through Moderna, clients can discover code patterns across an entire organization and target these for transformation. By pre-processing the source code as part of the build pipeline, transformations can be applied in seconds. And even if you're not a paying customer, you can still use their web interface to browse available recipes and even apply them to open source projects. This can be a great way to start contributing back to open source software. Find a project in need of some love and help them out by reducing technical debt. Personally, I've already migrated thousands of unit tests this way in WireMock, Apache Maven, and Spring. And it's a great step up to more interesting contributions. Just be sure that the effort you put into a pull request is more than the effort needed to review it. And if you find any migration steps missing, OpenRewrite itself is very accepting of new contributions. The community plays a large role in the development of new recipes. If you apply the recipes you've seen today to the Spring Pet Clinic project, you will find that it itself is not fully migrated. That, to me, is a very clear sign that we could all use more automation. And so with that, we are getting near the end of my presentation. The main takeaway is that you can perform migrations safely, quickly, and in full through automation. I hope you now share in my enthusiasm about the possibilities of OpenRewrite. And I hope you will consider contributing back to open source software, whether that's to OpenRewrite or Spring Boot Migrator itself, or by applying recipes to projects in need of help. Before we open up for questions, I want to recommend a few resources where you can learn more. There's extensive documentation and tutorials available on OpenRewrite. These will teach you how OpenRewrite works, how to apply common recipes, and how to develop your own. Development is all on GitHub, with new suggestions picked up with surprising speed. And as we've already seen, it's quite easy to contribute minor migration steps. If you want to try some recipes quickly on open source projects, have a look at app.moderne.io. And if you have any questions, I found the team behind OpenRewrite to be very friendly and responsive. And finally, if you would like to play around with the commands shown in the demo, I've written a blog post to accompany this presentation. The blog post migrates the same old Spring pet-clinic branch from 1.5 to 2. That way, you can play around with the commands and see the changes made at every step. For your own projects, I recommend you start with the testing framework migrations. They are an easy way to gain confidence in the tool and see what it can do for your projects. And that's it. Thank you for your attention. If you have any questions, just raise your hand. There's a microphone. And, let's hear. Oh, in the back? Yeah. That's you.
Hi. First of all, thanks for the presentation. The first time we saw the project, we foresee that it had a great potential, and we keep on believing that. Our team is using and reviewing some features of OpenRewrite, and we can assure that that the team is very is a quickly responder when we report any issue and they fix or improve. So that's a great team by our interaction, by our current interaction. And I have two questions. We found that for internal company use, we use a private repository, right? And we found difficult to use to upload our recipes, our internal recipes that are not going to be published in central Maven repo, and we find difficult to resolve, to download for our developers from our private repository. I think we opened a GitHub issue, and I think the team is evaluating if that's a bug, but I think this is very important for companies using customized and private recipes for their internal use, right? And the question comes here. We've seen the recipes tests are implemented in Kotlin. I'm big fan of Kotlin, of course. What we found that some members of our team that are not so familiar with Kotlin find difficult to mimic the tests for our own recipes, because the OpenRewrite tests are not so common tests. They are kind of special and maybe complex, right? And our team needs to learn from your tests, right? And they are very proficient in Java, but they are not literate in Kotlin. So that they find it a little difficult. Are you thinking on offering, not translating, but offering some sample tests in Java code?
I know for a fact that the team behind OpenRewrite, they have an abstract test base class that can also be used from Java. For their own recipes, they only use Kotlin for the multi-line strings, but it can also be used from Java. It's just they have not yet made available a first sample in Java. But there's, on their Slack, just last week, there was a discussion about exactly this topic. If there's a sample of a test case written in Java to convert an application. So if you chime in there, I reckon they can give you more pointers on how to do that.
Thank you.
Cheers. I think I saw one on the left. Yeah. Oh, there's a.
Hello. So thank you for the talk. I wanted to ask a bit more in detail about something you touched on. We saw the keyword fix in your presentation next to migrate, so it can also fix dependencies. So a really concrete situation in our company now is that our Jenkins build can fail if there's if a vulnerability is found in the national vulnerability database. So could this OpenRewrite automatically fix these dependencies? Because now we have to manually upgrade versions sometimes, and then we have to redo the Sonar scan.
So to recap, your question is if it can automatically upgrade versions of dependencies as well?
Of known vulnerabilities.
Of known vulnerabilities. Not specifically. They have some recipes for security, but that's more patterns in your code. And they also have recipes where you can define that you want a certain range of a dependency, which is not typically used in Maven. So some of the building blocks are maybe there to help you if you find a vulnerability to, for that dependency, use the range to increase it. But it's not out of the box that I know. So.
Okay, thanks.
Yes, cheers. Anyone else? Nope. Yep.
Thank you for the presentation. And for the person who is doing major migrations on a regular basis, you look rather happy. So the question is, did those tools kind of participate in that, or you are using something else to make you happy?
No, it's like I said, I really love that you get to work on these migrations because it gets you away from the mind-numbing feature that maybe otherwise would have had to be done. And I'm fairly efficient, if I say so myself, in doing these migrations. And like in the past, I used a lot of scripting. But now knowing there's a tool that can do a lot more than that, this is now my new favorite of meta programming tools to use to do migrations. Yeah, thank you. Then, one more, Alec.
Hi, I'd just like to ask, is there some support for like more complex refactorings, like automatic deletion of feature toggles that are,
I think that would be something specific to your situation, where you probably use a library or something homebrew for your feature toggles. But I think it would be possible indeed to find a certain feature toggle that you want to clean up and develop a recipe to find the specific conditional and clean it up.
Because I think exists some other library that does this, so I was just thinking if it's more appropriate to use that or this.
I'm not aware of any other libraries, so if it's hard for me to make the judgment call on that. But yeah.
Thanks.
Cheers. Then, yeah, the judging by hands, I think that's it. So thank you all for your attention. Cheers.